garu. Welcome you, sir. Today's webinar, PRECAST Construction, Joints and Connections by Professor C.B.Kameswara garu, retired NIT Warangal professor, will cover the details about the importance of joints connections in precast technology, various requirements for better joints and connections, types of joints. Before starting the webinar, I request Badam Sundara garu to address the webinar.
Good morning to all.
Good morning.
My special thanks to Dr. C.B.Kameswara garu for immediately accepting to have a lecture on precast construction joints and connections. I welcome Dr. N. Ram Prakash garu, Srikanth channel and other members to this webinar. Thank you very much, sir, for your attendance. And actually, we are very happy to announce you that our center is today's best center in industry institute relationship. We got the runner-up award for the year 2024. Every year, because of the support given by our members and more particularly our center's secretary's efforts, we are getting either 1 or 2 awards at national level. And I am highly thankful for all the members for their continuous support in achieving this. The precast construction activity is very much needed in India at present days because of labor shortage and labor problems. And to have more sustainability, precast construction is always advantageous. When we go for precast construction, the joints and connections are very, very important and very crucial. We are having Professor Dr. C.B.Kameswara garu to explain about the precast construction joints and connections, and we hope the members will get benefit of this lecture. Thank you very much, sir. Thank you.
Thank you, sir. It's my pleasure to introduce Professor Rao garu, who is the speaker for today's webinar. Professor Rao, CBK is a retired professor of civil engineering from National Institute of Technology, Warangal. Currently, he is Professor Emeritus at JNTU, Hyderabad. He is a graduate from JNTU, Kakinada, acquired his postgraduate and PhD from REC, that is NIT Warangal, India. He guided 8 PhDs and a few more in progress. He successfully completed 4 founded research projects, 2 more in progress. He published more than 150 research papers in international journals, national conferences, expert lectures. Professor Rao is working at IIT Bangkok for a term. He is a member of BAS Civil Engineering Division to Cement and Concrete Sectional Committee, Subcommittee 2.2, IRC Committee. His research interests include engineered cement composites, ductile concrete, retrofitting, precast joints, among others. He had 4 patents, 2 related to precast construction joints. I welcome Professor Rao garu to take over the session and start the lecture. Welcome, sir.
Sir, thanks for your good words. I'll start my session now. For all the participants joining today, I welcome and very good morning to everybody. This is a topic which is prepared particularly to give confidence for all the people who are hesitating to take up the precast construction. Because the main question that arises is that the connections only. Does these connections really stand, or does it really work out? So with this idea, I took this to explain with the help of the practical photographs, what have been implemented. I am not including any mathematical equations or designs in this entire lecture. I am just only focusing on the state of the art technologies only. So with this introduction, my presentation will consist of the just general introduction. Then I will take out the different types of connections and some innovations in the precast joints. Then my experience in the research with the precast joints at NIW. I hope I am audible to everybody, and everybody can see me also, hopefully. Sometimes I use my hands to explain certain things. And remember this cursor, this arrow mark, I will be using it to point out at the things. If you see the left photograph, the one that I am showing now, this is particularly nothing new about it. Everybody is very well aware of it, and everybody is very confident also using this conventional construction. We don't have any doubts, even if the concrete is a very poor concrete is used, or if there are honeycombs, or if there is any jointing is also not done. Still, we are confident about it. Right? This is a conventional construction. Now coming to the right-hand side picture, this is also very well known to us. We are highly confident about this. A steel structure where these members are factory made or cut into required size in a factory, and they are brought to the site and they are jointed. So it's a precast kind of pre-assembled, or we can say that pre-sections are there, already pre-engineered sections are there. They are brought and they are jointed. When coming to this joint, it can be riveted or it can be welded or bolted. We are thoroughly confident about it. We can design this for shear, bending, or different types of connections. Now coming to this construction, this is a precast construction. You can see this is a precast column and it's a corbel. Another precast beam is kept on it. Another precast beam is kept on it, and again decking is done by means of precast slabs. Then when it comes to this type of construction, a lot of questions arise. But my point is that if we can properly connect it, all these numbers together, such that this entire structure will act as if like our monolithic construction, then there should not be any problem. So finally, when we end up with the construction of the building, so it will behave as good as any other conventional construction only. So with this, I'll just show you, this is a building in Hyderabad where they have adopted three types of technologies. One is a conventional, the other is my one, that is aluminum type of shuttering that is being used. Then another one is the precast walls. All these walls are the precast walls technology that is being used. So all these, that means this building, once we use precast wall, precast construction, once it is finished, it's as good as any other equal structure. Now, if we just look into the basic thing, what is the main structural difference? What is the main structural difference between cast in situ and the precast structures? That means here, what is the difference? Because it's a cast in situ. Difference between cast in situ and precast structures lies in the structural continuity. Here, in this structural continuity, for in situ buildings, the inherent continuity is an automatic consequence of the construction process, because we are putting the shuttering and casting is done in a single go. So then the continuity is automatic. Whereas in precast structures, we have to ensure structural continuity when precast elements are connected. That's all the difference. Once this is ensured, automatically the structure will be as good as equivalent to the precast cast in situ construction only. Now, simply put, the joint and connection, a simple one. A joint is a meeting point of all the members in a structure, whereas this connection, a connection is an assembly of the adjoining members of a joint. That means here, when all the things are together, we call it a joint, and these members are when the connection is in assembly. When you assemble it by what is the means? Okay, you can think of different means of assembling them. And a connection is an assembly of adjoining the members of a joint. Now, what happens at this? Definitely at a joint, the actions of forces takes place at a joint, right? Just like our bending moment, shear force or torsion, whatever it is. So depending on that type of force, action of forces takes place at a joint, and connection to be designed is to be designed to resist the action of forces. So whatever is the connection that we are making, just like in steel structures, we fix up the number of bolts or number of joints or the length of the bed. Here properly the continuity of reinforcement or whatever is the connection that is required, that is to be ensured. So thus we can make a proper connection in case of precast structures also, particularly in concrete construction. Now, the Indian Standard Code of Practice, it particularly focuses, that is, this particular class says, precast structures could be analyzed either as an emulative system or a jointed system. So that means if the freedom is there, you can analyze the given structure as an emulative system or a jointed system. However, emulative analysis is typically preferred, where the structure is detailed such that the overall behavior of the building in its service life will be similar to a reinforced concrete building constructed in situ. That means if you can finally, the end product of the building, finally once it is constructed and ended up, if it is it will be similar to the reinforced concrete building constructed in situ, if it behaves like that, then automatically, right, you can say you can, emulative analysis can be, the structure can be treated as if it's a cast in situ or in situ construction, and emulative analysis is typically preferred, can be done to it. So here, otherwise what you can do is, we can analyze the structure as a jointed structure also. So either you can analyze it as a jointed structure, a jointed system, or you can treat it as a cast in situ system. So emulative system, that's one. So depending upon the type of analysis we make, how we identify the basic structure, accordingly construction has to take place. So the freedom is there. Now we have to choose a proper connection system there. Now requirements of a connection. As usual, it's quite obvious that it requires you it should have the required strength, the ductility. That means that the joint where it has the required rotation capacity must be there. In the case of an earthquake or anything, it should sustain the rotation and change in volumes, because we are putting a concrete again at the joint. Then there must be it should take care of the change in volume, combined shortening due to creep, shrinkage, and all these things. The durability is another one. It has to sustain that durability. The joint should have the durability. And again, as usual, the fire resistance also. Some other things are listed, just a written one. Now, there's a code, IS 15916, this 2020. So very much it's better than the previous earlier code, that is, right? This 2020 is a improved one. The building design and direction using prefabricated concrete, this is a code of practice that is available and this is to be followed in the precast construction. So here in this code, certain provisions are given, that is, like what is the kind of slabs that can be used, what are the kind of joints that can be adapted, and all this. So those things are, some photographs are here, some are taken, snapshots are taken and included here, right? So you can see this is slab, you can, these are projections are left out so that this, if this is cast, automatically the whole thing becomes automatically a completed full-fledged slab. Okay, so there are such provisions are there. So connections and jointing techniques and materials, what are the provisions that are given in the code? That is, again, this clause 9 says the jointing. What is the perimeter jointing techniques? Welding of cleats or projecting steel. That means the members, from the members you can provide a cleat or the reinforcement can be left and they can be overlapped, they can be welded. So welding of cleats or projecting steel, overlapping reinforcement, loops and linking steel grouted by concrete. So you can provide the loops and you can grout the joint. Reinforced concrete ties all around the slab. You can provide a all around the slab reinforcement can be provided and again concreted there. Or the members can be brought together, they can be joined by means of a pre-stress, right? So the best example is our box girders only, okay? Box girders. So epoxy grouting, that is the joints can be epoxy grouted. Cement or lime ground with a non-shrink additive, or polymer slurry grouting and double cast bolts and nuts and connections. Rebar fasteners, that means I can use just like a steel structure, I can as well bolt it or right for rebar fasteners, bars can be connected by using any mechanical system. Chemical fasteners and expansion fasteners or rebar couplers can be used. Combination of the above, anything can be done. And in addition to that, any other method proven by test. That means we can invent, we can come out with a novel method of connecting the joints, right? And if you can prove it by testing and show it, that also can be used. So there is a lot of scope for inventing or for finding out a new method or technology, whatever is convenient to the site. So it always happens. So in precast construction, there's a lot of scope for invention and introducing new techniques. These are some of the snapshots taken from the Indian Standard Code. This is a wall and slab system here. Again, a beam and wall slab system here, and this again the same way. And these are foundation and the wall system here. And again, these are the jointing by wall to wall and systems. These are the typically that is perimetered are given just as a schematic diagrams these are given to explain some of the jointing system. Right? Now I will explain the jointing system with the help of the photographs here. So different types of connections here. I divide this types of connections into column to foundation, wall to foundation. That means first is foundation, then connecting either a wall can be connected to the foundation or a column can be connected to the foundation. Next comes the wall to wall. Again, wall to column, wall to beam, column to column, beam to column, beam to slab, wall to slab, stays like that. Certain classification is done. Now here this that means what we are doing is the entire structure is now elementized. You are actually dividing into the different modules: foundation module, wall module, column module, slab modules, like that. Now they are to be joined one element to the other element. They are to be joined. So normally this is the standard practice. There are some standard methods are there. When standard solutions do not fit, and to develop innovative solution, the designer must be prepared to work with connections in a more creative way. So here is the one, when sometimes the conventional system may not work, then you have to think about a novel system. You can come out with a novel system also. So problem to problem, we can always come out with a proper connecting system. I'll now explain some of the connection systems one by one. Before that, a general classification here, there are two techniques that are adopted for in this connection or the jointing. One is called the dry joint, other is called the wet joint. The dry joint means The joint is accomplished by simple placing of two members by means of fastening. That means here, whereas, let me read out the bed joint also. The joint requires not only casting with cement, but also concreting and grouting material. That means here, there are two ways. The members are brought together at the joint. The concrete is poured, that's called the wet. The concrete is, the fresh concrete is poured in order to make the joint. Once it gets hardened, all the members, automatically the joint becomes a monolithic, it's as good as monolithic construction. Other way is, bring the members together, use either a nut and bolt system or a pre-stressing system or some other technique, right? Wherein we don't use concrete. So this is called the dry jointing technique. In wet jointing technique, concrete is to poured at the site, at the particular joint. In the dry joint technique, we avoid this concreting because that's also a big headache in jointing. So dry jointing technique, we use some other methods just by fastening only. So most of the contractors or the construction companies or the people, they like to have a dry joint because it avoids a lot of uses of making a wet joint. This is called junction casting. It can be avoided. So this is a basic classification. But most of the time, we have to go for now presently, the wet jointing technique is the most predominant and easier, whereas the dry jointing technique, it requires a bit of a specialization and a skill. Now let us look at some of the foundations. For some of the precasting methodologies, this is from column to foundation. This is a conventional method of construction. Just put the reinforcement for the column foundation, put the shuttering and concrete. Now, the other way is you can as well prepare as a module both foundation and column, and it can be a precast member, and this can be done at a factory or at the site itself. It will be lifted and can be placed at the site. And another one is a pocket. You can provide a pocket to it, a column will be inserted into it, and it will be jointed by means of a grout or proper jointing material. So here you can see this is again a column and this is a foundation. They are just placed one over the other, and maybe some kind of a grouting technique is used in order to connect it. So this a column is connected to the foundation. So another techniques is that here is a foundation, here is a column. The bolts are coming out, and here we have provided a plate and a proper provision where we can run it through those bolts, and you can just tighten this such that automatically the column is connected to the foundation. So this is called the dry jointing technique. So here what he has to done is this particular post should be capable of taking all the forces like shear, bending moment, and whatever it is, right? So this will be designed in order that it will withstand the whatever the forces transferred to this joint. So this is dry jointing technique here, and this particularly when we use this will be just such that it will not get rusted. Some concrete will be laid or it will be closed. That doesn't mean it's a wet joint. So, but it's a dry joint only. Now let us see the wall panel to the foundation. So here we have to prepare the wall panel, and the wall panel will be connected to the foundation. That means to the foundation there will be again a strip like a footing will be there. Right? This is a finished product. Right? This is a finished panel, wall panel. This is a wall panel to be cast. Right? Once we finish it, we can find this extra bar that is protruding outside. You can see, and this is all completed. And this is to be here. You can see these are the sleeves. These sleeves are provided, and at this end is closed. And again, the same kind of this extra bars that are there, protruding outside. You can see here. Once the entire thing is cast, right? These particular sleeves will be inside. You cannot see in this, but you can see here. That means there is a complete sleeve opening is there. Now what happens? Another piece, this piece can be brought and inserted right into it. Then this particular portion from this will be outside, and you can just open it and pump the grout into it. Once you pump the grout into it, these two panels will come close and become one panel only. So that is how the jointing will be done. So this wall panel, now this entire wall panel can be lifted and kept on the foundation. Now let us see how this is a foundation. This is a foundation from which the rods are protruding outside. Here also you can see the walls are protruding outside. So this is now the previous slide. These panels, once they are cast through these sleeves, it will be inserted right on it, and it becomes automatically connection to the foundation. One more photograph will explain this particular kind of connection. So this is actually the foundation, strip-like foundation here. You can say a raft is a raft, completely raft foundation. From the raft foundation, these bars are protruding outside. Right? These bars are protruding outside, and these are the wall panels, and there are sleeves here inside. These sleeves are brought and this wall panel is brought and kept on this. Automatically, it gets locked into it. Then there's here you can see the grout points. The grouting is done. So if you see here in the detailing part, once this is a sleeve, automatically corresponding to this, there is a bar. So this precision is required in this while casting. There must be proper alignment. If there is a misalignment, automatically it becomes difficult to insert these rods into this particular sleeves. So a precision is very much a high precision is required. With, of course, there will be tolerances in this, but it can be done. So this is the a wall panel, right, and foundation connection. So this is a finished product. You can see here. This is the foundation. This is the wall panel. In this wall panel, one more wall panel is inserted. So like that, the entire construction can take place. I'll take a few more examples in order to explain further. And since such gaps are to be closed, right? Will be closed also. That also I'll explain. While preparing a drawing for this particular precast construction, a lot of details are required. So here is a general drawing, right? But I took again in order to have a better visibility, this is presented by piece. So this is a drawing which explains how actually these sleeves are to be provided. These are positional sleeves. We will mark these sleeves, and the side connections again. These are the side connections. That is the wall to wall or side connections. That is how it is. These are to be marked. Again, it is 2, 7, or 5. The drawing preparation in case of a precast construction. If in ordinary construction, if you just make around 10 drawings, here maybe I think we may have to do 10 times the drawings, right? So very detailed drawings are required, and every minor detail is to be completely explained. Otherwise, production becomes difficult. For the production purpose, we have to provide all the details in this. So here you can see this is a corrugated sleeve. This is to be shown. This is a bar that is left over, right? Which will insert into the next one. And in this drawing, we will also have to show the MEP inserts also, right? Because these are PVC conduits or for electrical and plumbing activity. We have to show exactly where this is to be placed and all those details. So that can be inserted right into the precast element. So once the element is done, then there is no need to chipping off or anything. This is a detailed drawing. Now let us see the slab and wall connection. So this is a wall already erected, as we have seen earlier in our previous. The foundation is done. On the foundations, I have put the walls. Right now, the walls are resting on these walls. Now I have to put the slab. That is either it can be roof or it can be a floor. So for that, in this precast wall, this is a thickness of say 160, there will be a recess that is provided. So where we can rest our precast slab right on the wall itself. You can see this gap here. This will be used for the concreting purpose, right? Again, in situ concreting. There can be a small gap. This is called the backer rod. This end will be, we'll put that in this end such that the grout will not go out. And here also one stopper is provided such that the grout will not go out. So there is a grouting at the joint, and also in situ concrete will be laid. This is a schematic diagram, and some more details I can explain with the help of some more details. Say for example, the same drawing, if you see here, this is out of 160 mm. This 50 mm is the wall that is projected outside, up, and this is the seating arrangement of 110 mm is used in order to place the precast slab on the wall, and whatever the reinforcement that is coming in the slab, it will be bent, right? And it will be bent and it will be joined along with the reinforcement that is coming from the wall unit. The wire reinforcement will go right into the top of the next slab. This is the next slab, and this is the conduit that is provided, right? That is the corrugated sleeve that is provided. This projected reinforcing bar will protrude into this. This can be grouted, and this reinforcement will bend, and the topping, this is called the topping concrete, will be provided so that there is a perfect jointing is done for the slab, wall, and wall. So the jointing can be done. So you can see the different details of this. There is a projecting bars projecting from the wall, and this is a sleeve, and these are the bars, and this is a precast. Of course, if required, a temporary support can be provided. If it is not, if you feel that this is insufficient, only 1 or 2 supports, it will be sufficient enough. We'll go with few more details. These are the real structures where we have used for construction of the multi-story structures. The beauty of this is that this particular photograph will explain you. You can see this is a 3-level. That means this is a first 1 story, this is another story, this is another story. That means this one panel is actually panel is made in order to make three-storied panel here. That means here this panel is a 1-storied panel. So depending upon our elementization, our modularization of the elements can be done in such a way, depending upon of course, weight of this crane should be able to lift it. So suitably I can make as a single wall panel or a 3-wall panel. And these 3-wall panels you can see here, these panels are supported and resting on it. And I use a few more photographs in order to explain this. So precast wall connections and details here. So this is the wall unit. This wall unit, I have either a L-shaped connection, or I can have a T-shaped connection, or there is a continuity, or there can be 4, whatever is that. These are the different types that I come across. So this is an example for a L-shaped connection, and this is for the continuity of the member side by side here. Here the bars are, you can see this bar is looped like this. You can see this particularly, if you observe my pointer, this particular part is left open. That means that what a precast unit is, this precast unit is, this is the one unit, precast unit, and this is another precast unit having uncast part like this. These 2 parts are brought together, and there is a small gap, and that small gap of 5 or 10 mm, it will be closed with a backer rod, right? Some plastic tube will be inserted. And here we will put another stopper arrangement. So these are the loops that are going, protruding outside from the precast unit. We can see that. Then these are connected, and this is grouted or concreted, whatever it is. So thus I make the joint, one kind of a joint as the L joint I can make. So you can see the details of this particular connection here. So you can see how actually this grooving has to be done. So 40 everything, such a detail is to be given. So once this cast is, element is done, this is element one, wall one element, this is a wall two element, then this can be jointed. Similarly, the jointing can be done for continuous, getting a continuous wall here. So here is another one loop here, there is another loop here, here is a backer rod and it's closed and you can pour concrete. And this is the detail at this particular joint here. So this is a place where we pour the concrete. So this is the detailing that is required, and hence we can achieve the jointing of the wall to wall, either the corner or at any other in between intermediate jointing also, right? So I'll explain you with the real pictures here. You can see the corner joint. So this is a U loop here. There's another U loop here, right? If U loop is not directly done immediate while making the element, the bars are just left over, and this U is made and it is welded such that you can make a U loop connection here, and a bar is inserted, and here is the concreting will be done. So this I'll explain with a few more photographs. Here you can see this is called the looping. This is readily available in the market. You can get these loops straight away. So this loop inserted right in the wall element and cast, and this loop will be coming outside. This loops are again a rod is inserted and concreted. Either it can be a loop that is readily available, a shear loop, or you can make a U type of loop also can be done. So you can see this is the U loop arrangement here, right? Shear loop. This is called the shear loop arrangement. Now, if you look into this, the wall is supported here. This wall is supported. So you can see this is the grout points. So the grout points through which the grouting is done. And this is where the backer rod or something is used, and again this is the concreting is done at the joint, right? These are the lifting hooks. The lifting hooks here. So you can see some stiffener arrangement. When there is an opening here, we will provide a temporary stiffener such that no crack will be, then there will not be any cracks while lifting. And then this can be removed here. And this is a jointing. This is a backer rod. Backer rod is inserted and again grouted here. So these are supposed, right? This. Now, once this erection and grouting is done, automatically this becomes a completely monolithic joint. Further, the loop here is provided here, loop to loop. You can see the ground floor. This is the structure I have shown you in my first slide. This is a structure that is already finished right up to here. And this is the one that is going up, right? Blocked in. The ground floor wall, next floor wall, and the next floor wall is ready. And you can see the projections here. And here this wall will come and sit on this, and next floor will again can be erected. So these are the that will explain the method of sequence of construction and jointing of this wall to wall and wall to wall and wall to foundation on this. Now column to column connection. The one method of column to column connection is by providing something like a J-bolt like thing, and again this is inserted right into this, and this is bolted, and then a dry packing is done such that this will not get corroded. It's a simple technique, and like that the joints can be continued and column to column connection can be done. So here this is a dry jointing technique. The other one is we can provide sleeves in the column, and the bars can be left over, and the column can be kept one over the other. That means these bars will go into these sleeves, then it can be grouted. So then what happens, the entire thing becomes a single unit. So this is column to column connection, either by a bolted or connection or by the grouting connection can be done. Here, this connections, there are beautiful systems are available in the market. So this is a Growtech coupler. This is called a Growtech coupler. So the one bar is coming from this side, another bar is coming from this side, and we have a grouting Growtech coupler is there, and we can connect it, and we can just grout from one end and this, and then this whole thing becomes a completely one bar. And here is another type of a Growtech coupler. This bar is threaded is provided, and this is threaded and inserted to this. Here is a sleeve, the bar is inserted, and grouting is done. So thereby the bar becomes like a continuous bar or single bar. So this is further explained with the help of another diagram. Right? So that means we have a system that is already developed in order for the continuity of the bars and providing a jointing technique for the element to element here. So the other technique is by rivet. Here is the rivets are there, they are hammered. By friction, it develops the continuity, or by threading, it can be continued. Here is a coupler, a threaded couplers here. So these threaded couplers are used in order for the continuity of reinforcement. Now beam to column connection. Let us see some of the examples of the beam and column. Of all the things, the beam column connection is the most typical. I can connect wall to wall, wall to foundation, wall over the wall, horizontal. There's not much difficulty. But when it comes to beam column connection, automatically it's going to be a crowding. Even in a monolithic construction, even a conventional construction, beam column junction is a very typical one. We get a lot of reinforcement there, and concreting becomes difficult. And more so in the case of our buildings with the precast elements here. Let us see how this is being done. I'll try to explain with the help of photographs here. So these are the typical arrangement, standard arrangements. That means here the top, the entire beam, the top portion is not cast. These are left over, these stirrups are left over, and the reinforcement can be inserted, and they can be made continuous, and they can be cast after bringing it to the site. This is half cast precast beam. This is the precast column. This is another half cast precast beam. They are brought together, kept it here, and actual in situ concreting is done. Right. So this is again another example where I can use a point of contraflexure as my jointing. Practically how this will be done is the top here, this may be the end one, and hence of the entire beam, this portion is cast such that if I put the concrete, I don't need any shuttering here. Automatically, here is a slab that will be sitting on it. These bars are bent and taken into the column, and the bottom bars are bent, taken into the column. Here is this becomes really a very congested area. Here it becomes a typical challenge, a challenging area where we have to deal it very carefully, and also detailing is to be done such that there will not be any clash between these bars. Okay. So you can see this is a precast beam again. Out of this, the entire depth, some projection is this is the width and the projection is left, right? And our slab can come and sit here. This is one side. This you can see the side, both sides. Both sides. This can be used for sitting our slab. On the other side, we can keep our slab. And these are the projections that are coming out. That is our shear loops, shear rings, and through which I can put the reinforcement. These are the bottom bars taken right into our column. I'll show some more photographs in order to understand this kind of arrangement. Normally, what happens to keep this beam on there, we require a corbel. A corbel is required because the proper seating is required here. Right? So a corbel is provided to the column, and on the corbel, the beam will come and sit. And now the question of arranging the reinforcement, it can be with the help of a cleat, some kind of a cleat that can be connected, or it can be a cast in situ construction, can be in situ concreting can be done. That's a wet jointing technique can be done. So typically you can see how the beams are placed on the columns here. And you can see the shear loops are left over, and this is one stage. The next stage also you can see. Here you can see this is the factory at Vijayawada. Now this is a column. You can see the column. The projections are made such that the other beam will come and sit. You can see this is the beam sitting here, and this is a beam sitting on this one. Now this one, the one that is the column behind this is a one floor. This is the second floor, the third floor. That means if I say take the ground floor, first floor, second floor. The entire three level column is made as one unit and brought to the site, right? And at some points only one floor level columns are used. It all depends upon our the elementization here. This will explain how the beam is kept on the column. This is further explained with the help of few more photographs here. This is a column. In our design, in our structure, what happens is all the beams may not have the same size. Some sizes will be less, some is deep beams. Here you can see this is a shallower one, this is a dark. There can be a depth of the beam here is more, here the depth of the beam here is less, and we have to match it, we have to provide proper corbel, and again we have to invent a method, or we have to come out with a novel method of placing it. It's a small piece, you can see here, they are brought and kept on it. So this is a beam and column placing system here. Then the extra bars are taken into it, and now further the jointing has to be done. So you can see this is the ground floor, the first floor, the next floor. Here at this end, another beam is kept. You can see this beam is kept on this cantilever end. This is the cantilever end. Another beam is kept, then the slab is laid. So I'll explain you all these jointing techniques, or the connection of beam to column and another slab and all, with a few more examples or photographs. Now you can see this. As I said earlier, this is a beam, right? And the top rings are there, reinforcement is left, and again, in order to get a continuity, the bars are left, and these are threaded already, and L bent is L-shaped bars are taken. The threading is done, and they are connected to that, such that there will be a monolithic construction, or there will be a proper jointing can be done, and continuity of the reinforcement is achieved. So here this is bent and taken to the column, and when there is going to be a congestion, then we'll use this kind of a coupler, right? And a L type of bar is bent and threaded, and they are connected. So then I can achieve the continuity and the fixity or the rigidity of the joint. Once this is cast, it becomes as good as a monolithic construction only. And cast is it's equal to the cast construction. So that's called emulative analysis, emulative construction. Now the finished one, you can see, right? These are same structure with this is the end one, and these are slab. I'll take a few more examples in order to explain this particular jointing technique. Right? It's a mechanical connection here. You can see this is a kind of a well-designed one. A sleeve is there, and bolts are connected, and these are taken. So all patented. So, okay, a patented system. This is a dry joint technique, eliminating system components for typical beam column joints, precast reinforced concrete structures. That means all these are inserted and these are bolted. And here is the full connection detailing is done. Another kind of connection here. It's a dry jointing technique again. You can see the cleats here. You can see the cleats here. And these are the steel plates. Their bolts will coming out and they are bolted straight away. So thus I can achieve this kind of a joint can be made without using our wet jointing technique, wet jointing. So while the beams or columns are connected, then on the top of it the slab elements can be placed. Another kind of a bolted connection. This is yet another way of, as I said, you can come out with different ideas of connection systems. This is a column, this is a small corbel-like thing, right? This is a beam. While casting the beam is cast with a projection, says that this will go and sit here, just like that it is sitting. So that means here, this projection, this end is such, I can have a seating arrangement, and this is the wall. This acts like a side shutter. This acts like a shade shutter. In between, inside is the hollow. Inside is the hollow region. Once this is kept, once this is placed on this, I can put concrete right into it, and I can make it as a continuous one here, right? And of course, the projected reinforcement can be used in order for the continuity and for the fixity and for the monolithic kind of a thing. So hybrid connection with the shell beams. These are the shell beams. Like that we can innovate it. And further you can examine, you can see, understand, these particular sleeves are used in order to run the reinforcement from one side to the other side here. Okay. This will be running from one end to the other end. Reinforcement can be run on this side. So several innovations can be done. This is a crucified joint. That's a plus kind. Then this is a straight away, right away, inserted right into the column. A proper continuity is achieved by this, okay? Proper into it. This is a beam column connections. They should be careful while doing it. So there should not be any such mistake happening. Or a welding, sometimes it is done, it is to be done properly. Now the slab beam or slab wall connections. These photographs will explain how this connection is. The first one is the slabs. In the slab unit, again there are different types of slabs. You can make a solid slab, or filigree slab is there, or hollow core slabs, or double T beams. Like that, different kinds of techniques are there for the slab system. Of this is one, the hollow core slab, hollow core units are there. So it can be manufactured and is can be brought to the site and can be actually placed on the beams and slab system. So we have the production. Now you can see that. Let us say this is the wall units. On this wall units, it can be a beam also. Right? So these are the wall units. On these wall units, they are already erected. On these wall units, from wall to other wall, the slabs are laid for it. On the wedges, as I said, that 110 mm is used for the placing it. Then after placing, in this hollow core, the one of the hollow, they will be cut. It will be cut like this. So once you cut it, the bars that are protruding outside from the column, some of the reinforcement will be used to bend right into the slab itself. And as this entire thing is a hollow, this end part of the cutting will be closed by means of some polyethylene or something like will be inserted into it. Just like here you can see, these portions are closed such that the concrete, once it is concreted, that will not go into the hollow core slab, and here also it will close. So once this is bent, then automatically there will be a fixity that will be coming into it. So this is a wall unit. On the wall unit, the slab unit is placed. Right? So this is to explain this particular portion. As you can see, this is the propping up. The next slide. Right? So typical hollow close sections here. So this is the cutting. As I said, as I told you, this is a cutting that is being done. That means this cutting is done. Where to cut, I have to show it in my drawing. And this is the 2 units, and this is the joint between the 2 hollow core units. And after that, then in this particular joint, we'll use the reinforcement, right? Reinforcement will be protruding outside from this one. This is the kind of reinforcement that will be kept inside again on the wall. And then it will be concreted. On the top of it, on the top of the slab, again using this reinforcement, there are concretes, this is called the topping. The topping concrete will be laid on. I will explain you with the help of some photographs. So these are the sleeves through which the reinforcement is inserted right into the slab itself in order to have the fixity or the continuity. Now you can see this is the column, the beam, and the hollow core slab is resting on the beam. Earlier I have shown you the same photograph. This is the beam. If the beam is resting on it, there is a projection on either side. On these projections, the hollow core unit can be placed on it, such that this will be used as a seating. Now this will explain how actually the hollow core slab is placed on a corbel column, a corbel hollow core slab. Again, this is a place where we do not allow any concrete to go inside here. The stopper arrangement and the reinforcement will be continued. So this is a detailing part for the casting and construction part. Now you can see how actually the whole thing is made. This is a column, the beam is placed on it. Of course, the reinforcement will be protruded. On the top of it, the hollow core slabs are laid, and you can see these cuttings through which the reinforcement will bend, and on the top of it, we'll put reinforcement. Again, this is called the topping reinforcement, and topping concrete will be laid, such that the whole thing will be made as a one monolithic unit here. Okay. The finished product you can see in the under this mesh. All these units are the hollow core units. From between the joints of the hollow core units, you will see these rings like this. Through these rings, this reinforcement will be passing. So thereby, that means the hollow core unit with these rings, they like a shear connector, and with the stop reinforcement and all this, these are the beams, right? This once it is cast completely, the whole unit becomes as a one unit only, a monolithic construct. It's as good as the cast in situ and monolithic construction. So now this is a finished product. You can see the column and this is a beam, and we have the hollow core units. This is a finished product. You can see. Few more photographs will explain this pattern. We can use a hollow core unit or a double T slab or a solid slab or a single T slab, right? Because the double T slab is kept on the walls at the projections here. Now we have seen foundation and the column connection, foundation and the wall connection, wall to wall connection, wall to slab connection, and column and beam connection, and on the beam the slab. Also, you can see here the finished slabs. So this is a staircase. The staircase are also made as the precast units. The staircase, as once is made here, there will be sleeves. The reinforcement can be protruded right into it, such that once it is placed, that fixity can be achieved. So this can be rest on it, and reinforcement can be protruded. All precast such staircases. I'll explain you with another photograph. This is a precast staircase unit. You can see this hose here. The reinforcement will be protruded right into it, and it will be grouted. So this will be like a shear connector, so that here also they will be connected totally, such that we will have a complete rigidity and full continuity, just like any other monolithic construction. All units are precast over here. You can see the projections here. Now some innovation, I'll just speak about some innovations. Now the time is 12. I think I may take another 15 minutes to complete it. Some innovations here. You can see this is a beam wherein a channel is inserted right into it, and another channel, another I section is running right into the column section from one side to other side. So here you can see the joint by just like any other in a steel structure, right? How we connect the web to web and flange to flange, okay? The splicing arrangement. It's just like a splicing design. We can just connect it and then it's bolted or welded or whatever it is. And the rest, then the whole thing will be concreted. This joint cannot be seen, this whole thing can be concreted. The other way is here you can place it, you can provide a cleat here. And as I said earlier, there is a I section inserted right into it, and these are welded, these joints. Different types of connections can be thought over and can be innovated, and it can be tried, it can be tested before using it. This is another kind, it's called the cogging joint. You can see cogging joint, you can just see this kind of connection. Then this is our gasket, this is bolted, they're all bolted. So this is called the wet jointing technique here. The precast column, and this is a precast beam. A channel is used here. Here is another channel like thing. The bolts are already inserted, they are just inserted and bolted, and it will be concreted again. Then this whole thing becomes a beam column, a good beam column joint. Such beam column joint need to be tested before actually, whenever innovating or coming for a new kind of a joint, this will be tested for its kind of static load and also the dynamic load. This is another kind of a joint, right? Where this joint is, the beauty of this joint is that whenever we want, we can as well joint it, or you can unbolt and again disassemble all the members and take to some other place also. The assembly can be done, and disassemble can be done also. So this is a kind of a joint that is okay. Some more details of that particular kind. As I said, this is again a jointing technique. Plates are there, I sections are used, they are welded, different kinds of connections, some innovations. So such things are to be tested for both cyclic loading and static loading. This is using a UPC, that's ultra high performance concrete. Reinforcement is left on the top and is taken inside, and these are the grouted couplers. These are the couplers here, and the bottom reinforcement going inside, and again that was sitting here. Column 1, column 2, and this is a beam. Finally, once this is cast, right? Here we are using the ECC, engineered cement concrete, ultra high performance concrete used at this particular joint, such that there may be a M120 of that kind will be used here, such that we will get the full rigidity of the structure. This is one kind of a. So there are all the research and innovative techniques. Here, as I said earlier, we use the loops here. The U-loops are used in order to join the wall-to-wall arrangement. One innovation is that a rod is here in this particular element 1, which is element 2, a tube is inserted, another tube is inserted, that means there's a hollowness is there and hollowness is there. before bringing it to the site, a rod is inserted like this, a reinforcement rod is inserted, and something like a screwdriver, something like a driver. A driver arrangement will be there, a small hole will be made here, and a driver arrangement it will be inserted just like this here, right? It will be inserted right into it. Then once it is driven, once it is just like a gun, if you push it, automatically it will rotate and the bar is moved from one side to the other side automatically. Then this is rotated. So such kind of joint is not required. So it's a simple technique. You are avoiding concreting at this joint. So it's a kind of a dry jointing technique. So this is again a patented one. PRECAST construction company in Pune, they have made this invention and patented. So another way is need not be completely concrete. It can be a composite type. So you have here the steel frame, the beam columns are the steel, and the decking is done by the hollow core units. These are the hollow core units are placed on it. And of course, proper welding and proper shear connectors will be done, and the structural concrete topping is done. So composite kind of a construction can also be taken up here. So not only in buildings, the precast techniques can be applied to any other structure also with a proper identification of the elements and can be transported and can be done. One such thing is in the precast construction transmission towers. Already there, myself and Prasad made it, and we have verified the design and all those things. That I will present it here. So this is a conventional foundation for the large towers. It's a very huge one. Right? This one. In a hilly region, it's very tough to take concrete and do the concreting and preparing these foundations. So one company requested for a precasting of these elements and doing it. So this is a conventional construction, right? Reinforcement and all. So this is one technique of precasting of the foundations. Now, this is a problem that we have arrived at. That is this is actually these are the forces on which the foundation has to sustain. And this is made into 6 elements. The foundation base element is made into 4 parts, and the top element is made into 2 parts. These are the 2 parts. Totally, this complete precast foundation is made up of 6 elements. And these 6 elements are assembled in order to make foundation for the tower units. Okay. The next slide. These are the drawings. So these are okay units. This is one unit, the other unit. They are joined. The top unit. These are the bottom units. So once we join all those things, it will be like one single unit. This is analyzed using a software antenna. I have done this analysis modeling, numerical analysis is carried out. So this is again just exactly, this is simulated. How exactly this is being done as a precast elements. Precast elements, 4 elements. The 4 elements are precast elements, and the 2 elements are again precast elements. I have modeled all these 6 elements, and this is the tower reinforcement, right? All this is modeled, and I run it by using the antenna software and verified whether the design, whether the board and the connections that I have provided for connecting these elements, all these 6 elements connecting together will be withstanding the forces acting on the actual force acting on it or not. So once this is verified, and then it is proof tested. Actual testing is done at the site. So in order to conduct that test, again, we have designed a huge transverse beam and a connection system and a jog system is designed, and I'll explain with the help of the photographs. So this is the test arrangement test beam, right? Reaction. This is called the reaction beam. Here, this is the one I am standing. This is Prasad, Ajay Prasad. Right? And this arrangement is actually test piece is here. This is a test piece, and for which I'll put the jock and I'll pull it or push it. This is a reaction beam. A real testing has been carried out at Pune. This is this will be used for the Georgia, in the country Georgia, the PRECAST foundation for the towers. There are few photographs that will illustrate. You can see the size of the beam here. This is a man. Now, my experience at NIW regarding precast jointing technique. Commonly, if you look back into our previous slides and all, where exactly we find the difficulty is the continuity of reinforcement any joint. So once the reinforcement is made continuous by somehow and it is cast, automatically all the units become as a single unit. For that, what is the technique? The first one is we have to put sufficient overlap here. If you overlap the bars and concrete it, automatically you are getting the complete, this is conventional. Or sometimes we use the U-hook arrangement here, or we use the coupler, threaded couplers are used here, or this is the grouted couplers are used here. Sometimes the headed bars are used here. These are the different techniques. All these techniques is to avoid this overlapping. The overlapping can be avoided is one, or the overlapping can be reduced by using these headed bars or by this coupling arrangements. That's right. It's only just threading and connecting it. Here, this is a small shank into which I have to insert the bars and grout it so that I get the complete continuity of the bar. And this overlapping, that means LD. LD is a joint that can be avoided completely. Now, I came out with an idea that if this end of the bar, if it is bent into a helical end, then it provides a very good anchorage. That was the idea. So hence this research is being carried out by using the helical end rebar. That means in our precast construction, the joint should be as short as possible, as minimum as possible. So in order to reduce the overlap length should be reduced. To reduce the overlap length, we have to increase the anchorage. So for that, increasing the anchorage, I just made this end as a helical end. Naturally, any helical end automatically provides a very good anchorage. This is obvious. But how many? Now, how many turns are required? What is the pitch and all these things are required? So this is being done here. Like these are the helical ends are prepared, and first of all, initially pull-out tests are carried out. What is the bond? How much is the anchorage that is being induced into this by making a helical end? Then again, as I said earlier, that Atena software numerical model is prepared, and initially it is verified by numerically analyzing it. If I insert into a concrete and if I pull it, how much anchorage this will provide and how many number of turns are required, all such things. This numerically, this finite element modeling is done and is analyzed. And once we have come out with the show, then a beam is tested in parallel. Here is the 3 bars are there. These bars are continuous bars. That means a conventional construction. And this bar is cut, and bar is again one end is made one helical and another helical. They are overlapped. Here I have provided the stirrups. Here there are no stirrups here. 3 beams are, I'm just only few beams, but it considers for quite a good exhaustive testing, a big work, and it's concreted. This is the overlap that is being done here. Right, this is how we can make a simple arrangement of a spring making machine can be used in order to make this helix. Hello? Anything? So these are overlap.
Yes, sir.
These are tested, and you can see the beam with continuous rods and with overlap is Again, verified, they are matching here. So again, this also model is tested using again antenna model, antenna software, control beam, and the control beam, the P delta curve here. Again, this is a overlap, that 5 times diameter of overlap here. Just 5 times diameter of the overlap, okay, with just a few turns. Overall, it will be around, the joint will be around 12 times dr. So this is a P delta curve, and these are matching here. A patent is again got a patent for this, and no means of anchorage for reinforcing wall. You can verify this if you put this 528,583. This is a patent number. If you strike this 528583 in our Indian patent one, you can see all the details of this particular patent. Like this, few other patents are also there. Now I am concluding. In a precast construction, the major challenge is the joint. I can make the members in the factory, and with all precision I can make, but bringing it to the site and connecting them is a big challenge. So problem faced by the precast industry is finding a reliable and economical method to join prefabricated members. A dry jointing technique is very welcome. Wet jointing technique can be used, but again there is a kind of a problem of again concreting, pouring concrete, and looking at avoiding the congestion of reinforcement. All these things are to be addressed, right? Hence, joint is the main issue, and we have to come out with the proper and easier methods of jointing the members. And of course, summary, it's a conclusion. Now you can refer to these books. These are whatever the information I have collected is to the books and my field experience and the photographs taken from the field and my research work. The PCA design handbook, it consists of a lot of information and structural connections for precast concrete buildings. FIB 43, here is the bulletin here. The Singapore also they have come out with a booklet here. So these booklets you can refer, and you can get a lot of information about not only about the precast construction, but also about the jointing. Here remember, I have not dealt with any of the design methodologies or the equations like how to the shear force, bending moment, all such things, the reinforcement, these things I have not dealt. So there's a proper designing of the joints is there. Okay? There's a proper, just like we design the steel structure joint, we can design the RCC concrete precast members. So with this I conclude. Thanks for your patience and all. Okay, and if you have any questions, you can ask me.
Thank you, sir. Thank you very much. Excellent presentation, sir. Very practical oriented and illustrated the theory with the real site photographs. With this presentation, we are clear that you did a lot of research work on the precast construction joints. Now I request the participants to raise your questions.
Hello, sir.
Yeah.
Good morning, sir. Very excellent presentation, sir. I have two questions, sir. One is with respect to the rebar couplers, what we are using for the jointing purpose. Is it required for the quality control point of view, any testing for some of the couplers that we have used in any project?
Yeah.
Or simply 100% tension transfer from the joint of rebar coupling?
Yeah, it's always good to have a test because we have tested couplers, right? Grouted couplers we have tested right in our laboratory before using it. Even for while using this grouted coupler for the precast foundation unit of a tower, right? So we have tested the couplers completely, and grout is more important. Grout is grout is the essential thing here. Grout also need to be tested separately, and coupler along with the grout, the finished product is to be tested. And in fact, they will arrange also. There is a method of testing also. There is a code for this how to test a couplers. Right? If you are aware it, you can refer, but I straight away I'm not getting the number, right? But there is a code for it. So I advise if you are using a grouted coupler or anything, better test. There's nothing wrong in testing 3 or 4. Okay, good to all.
Second question is, sir, like in the case of a steel structures, we are analyzing as a rigid joints and the semi-rigid joints.
Correct.
Is it the same philosophy can be applicable for these precast elements also?
Here, that's what exactly. Here, in the case of our reinforced concrete structures, I said emulative design. Emulative means almost like a similar to the this one. Emulate means emulation of what? Of the cast in situ construction. In cast in situ construction, what is the joint we are assuming? We are assuming it to be a rigid joint. So
Yes.
our analysis, what we do is our analysis, when we do the analysis for a precast structure, what we do is we treat it as if it is a ordinary rigid jointed frame only, nothing more than that. But in order to realize a rigid joint, how actually this is to be, how the bars are to be connected, what is the kind of joint detailing is required, that is important. Okay. Now, in some of the types, in some of the considerations, what we do is we treat the beam as if it is resting and simply supported only on a cord that sometimes. So then you have to put that as a joint there. So that means it can be treated as a jointed structure also, right? So once whatever is the analysis we are carrying, the analysis is done just like the one that we use is what that we do in our any other structure as a, and whatever is the model that you are making there, if you are treating it as a hinge, then that hinge is to be realized there. Am I
If you
clear now?
permit, yes, sir. If you permit me, I have two more questions, sir.
Right.
Sir, regarding the elastic deformation curve of the entire structural system, is there any measurements of the elastic curves of the total system approach for the precast buildings?
No, that
Like
is
deform.
So you see, whatever are the clauses applicable for any standard, any other conventional building, all those are applicable even for precast structures also. Apart from that, there's one more clause for these precast structures. You have to conduct the progressive collapse. We have to analyze the structure for progressive collapse also. But this is the additional condition that is given for the precast construction building. Right? So in case of any particular member collapses by any chance, there should not be any total collapse of the structure. So whatever are the conditions, you take anything, right? Deflection criteria or sway criteria or the drift criteria, right? Whatever is the conditions that are there, right? All those are applicable even for precast construction.
Right, sir. Last
Am I
question,
clear now?
sir.
Am I clear?
Yes, sir. Yes, sir. Last question, sir. Regarding you have used the spiral ends for the jointing purpose, that is for the end anchorage purpose.
Yeah.
Have you used that as a twist, interconnecting of these two spiral ends, or a simple placing of one end over the other?
No, this is see in case if there is a overlap, right? The overlap of the bars. So this is a continuity of the bars, is not overlap of the bars. Overlap
Yes,
of the
sir.
bars is required development length of equal to LD. Now I don't
Yes.
use the development length of LD. I use only 5D or around 5D as the overlap. The remaining is 3 turns or 4 turns, whatever is required. So totally it comes around 10D or 12D is my total joint length. So I get the just like overlap. Suppose if you provide a overlap, are you not sure that the bar is continuous? You are
Yeah,
sure.
ball.
You are sure.
Yes.
Similarly here, if you provide the bar with the helical end on either side and overlap it for 5D or 60, depending upon the forces because of the moment and all, then automatically it's as good as a full overlap.
Yeah.
So that means
One
what I am
point
doing here in my thing is the overlap of LD or that 58D or 60D or whatever it is, I'm now cutting down to around 12D, that's all.
Sir, what I exactly want to have is have you twisted the two ends of the spirals, or
Right.
simply you have put it side by side?
Correct, I have twisted the ends of the spirals, and here this can be done very simple. You can, if you are interested, I can just put this right there.
Fine, sir.
There's a small YouTube is there. You can, if it gets loaded, you can see. Is it still are you able to see my screen?
Yes, sir. Yes, sir.
Yes,
It's
sir.
a
Yeah.
YouTube.
If it gets loaded, you can see it. Okay.
Fine, sir. Fine. Thank you, sir.
I just
Thank you,
kept
sir.
it ready in case if somebody asks, I just want to show it. Okay. Next. Any other questions?
Sir, you have 4 patents, am I right, sir?
Pardon me?
You have 4 rated, 4
Yeah,
patents.
I have 4 patents.
2 are precast related. Now, what are the other 2, sir?
PRECAST, one is, this is the one I told you that overlap, right? Another is the helical interlock arrangement is there, another one, right? And this is the overlap arrangement. Another is the helical interlock arrangement is there. So that is another patent. The remaining 2 related to some other thing.
No. Any questions, sir? Sir, there is question in chat box, sir.
This is the one you can see. This is getting loaded. Okay. Are you able to see this? The video?
No, sir. Your presentation only visible,
Are you
sir.
able to see the video?
No, sir. The presentation is only on the screen, sir.
Oh, you are not able to see the video? Anyway.
Yes, sir. Yes, sir. Not able to see the video, sir. The presentation is only on the screen, sir.
Yeah, of course. Okay. Anyway, you can. It's a very simple one. You can actually go to any website and see how actually the helix are made. Automatically, you can understand. It's not a big technique, right? Any spring making machine fellow can be able to do this helix. Or even this can be done at the site also. You are actually turning 90 degrees, 135 degrees using your bar bending machine, is it not? So if you can put some other fixture on it, automatically you can make the helix also on the same machine. So the same bar bending machine can be used in order to make the helix. You have to just slightly improvise, right? That's all. Okay, is it clear now?
What is the helix angle you are proposing, sir? Helix angle?
Pardon? That
Helix
is to be
angle,
designed,
sir.
actually. How many number? Helix is very that I minimize it as see what my requirement is. I have to minimize the volume of the joint totally. So I have to use the minimum diameter possible, and I have to use the minimum number of turns and minimum possible pitch, for which I developed the design equations already, right? For that is designed.
There is question in chat box, sir.
Yes.
What are the notable?
Could I complete with Dr. Rao? Is it clear? Dr. Rao, did I answer your question?
Clear, sir. It's clear.
All right, okay. Next.
Yes.
Yes, sir. What are the notable challenges for installation and transportation of precast beams, column slab? Also, any other challenges?
Yes, we have to properly design. That means while designing, while selecting the element itself, what is your crane capacity? Is it 5-ton crane capacity? Depending upon the crane capacity and also your trolley length, right? Your vehicle length. And see, I told you there is a ground, first, second, the 3 floors. A single column is cast in the factory and it is transported to the site. So that means your trolley length, right? Your trolley capacity, then your crane capacity, and these things are to be studied. Based on that, we actually design the elementization. So elements have to be first of all checked, right? So these are all interlinked things are there. So C.A. Prasad is also there on the line. C.A. Prasad is attending. Yes, sir. Any other question? Yes, there are challenges. It can be met.
Yes, sir. Hope there are no questions, sir. We will conclude the session with my vote of thanks. Thanks to our chairman Badam Sundara Garu for his valuable time and support in this webinar organization. Thanks to all our ACCA members, headquarters team for the support and encouragement in this webinar organization. Students, friends, faculty, co-engineer friends, our member Sairam, Engineer C.A. Prasad Garu for his guidance and speaker arrangement and all the coordinations made in this webinar organization. Finally, today's speaker, Professor C.B.Kameswara Garu, for the wonderful lecture, which is very, very helpful to the all consulting civil engineers who are in and looking for precast technology. Thank you, sir, for requesting our for accepting our request and arranging your valuable time, particularly on this Sunday time. Thank you, sir. Thank you very much.
Thank you very much, sir. Thank you all the participants. Thank you, Prasad Garu. Prasad is there. His video is on.
Yes, sir. Yes, sir.
Thank you. Okay.
Thank you, sir.
Right.
Thank you.